So we discussed user space ZFS, OpenZFS, I'll say. And then this notion of real-time replication has come up for years and years. A lot like package-based and FreeBSD, where it's been this neat idea for a very, very long time, and only recently has someone said, let's rip off that bandage and do it, and make some hard decisions, and some hard fixes, etc. And following that metaphor, real-time replication has been coming up. In my decade of TrueNAS support, everyone wanted a cluster, or they thought they did. And they had the budget for 1.5 machines. And I'm like, so you have a quorum of what? And they're like, oh, what is a cluster? But I know I want it, and my boss wants it, because once you have a cluster, you don't have to worry anymore, right? It's like, well, no. It's a bit like a puppy or an Italian sports car, where there's a lot of care and feeding. The setup can be a lot longer, and feel free to just search the recovery procedures for the clusters and cephs and all those options. And people get really quiet really quickly, where in ZFS land, a disk replacement is a very well documented, very predictable, very stable part of the experience. And we'd like to see that consistent experience across the board, would we not? Such that, correct me if I'm wrong, I overheard that user space ZFS, OpenZFS, might be the building block for a easier to build, easier to maintain, easier to get adopted real-time replication. Chris Moore, do you want to repeat your narrative on that?
There was just a bunch of us talking here about that. It may help development efforts, if anything. It's just easier to get set up and test.
Use cases.
I would defer.
I trust you have a use case or two up your sleeve with your constituent.
Defer to the experts who would, discuss how difficult it is to go and do real-time replication. But, we have use cases. You mentioned it. And customers say we want a cluster until they actually learn what a cluster is. And then they're like, oh, we don't want that, but we want these properties of a cluster. All right. At a small scale, we're usually talking 3 to 5 systems. We're not talking hundreds. We're talking single digits, low single digits. Is that something we could potentially find a way to grow in ZFS? I mean, you want a sexy marketing feature. There's one.
I see Rob is lit up and is shaking his head. Does he have something to say?
Yes, please. Rob, it's good to see you. Cheers. We don't hear Rob. Patrick, we don't hear Rob from Zoom. Yep. Hey. Go ahead, Rob. Do you hear us?
Oh, I hear you.
We can now hear you. Welcome.
That's great.
We can hear you now.
Well, thanks. Good afternoon, everyone. I was just saying I'm going to be a little bit shaky because I've been awake about 15 minutes. So, but I've loaded up on coffee. Yes. User space OpenZFS is like my number one personal want, and has been for a while, and I continue to work on the sides, and there's about 20 use cases. So, but they're on replication specifically. Yes, building in user space is, I mean, I would build everything in user space, but also I think it's possible to do. It's been built before for databases mostly, which we are a database, so that's fine. And I've like it. It's very doable. There are some problems to solve, but you get a lot once you can start the two. It doesn't have to be a cluster like a quorum kind of thing. You can even do just having active replication between a peer. Just one is a primary and one is the like the backup, but you are keeping them in lockstep. And you have whether you have a floating IP or whatever you have, a load balancer, some kind of failover protocol. Yeah, that's basically what I was nodding at. I thought about it a lot. It's hard, but tractable. And user space is a good place for it because you don't actually have to have the all you need is the disks. And a way to get the data in there. You don't actually need the kernel for any of this stuff. In fact, you wouldn't want to, because you want want a lot more stuff around control, around visibility into what's happening. You want logs for that sort of thing. You want to be able to, you want to be able to do lots of stuff. So I realize how vague that is because Alan saw me nodding, and this is basically my big noisy nod. We can do that.
Do we have prior art from some science project that one of you or your colleagues did a number of years ago?
Me?
Any of you? Whoops.
Oh well. Not specific, but I not specific to OpenCFS, but I wrote and maintained for many years a multi-master replication for MySQL since version MySQL 4, I think it was when we started it, and yeah, it didn't have the ability to do that out of the box till 8.26, I think. So that was only a few years ago. Yeah, and I mean, like, it sucks. It sucks to operate. It's like, now you have a cluster and now you have a bunch of computers, and so you get a bunch of things that can break. But yeah, I've done the flight, and then a friend of mine now works at MongoDB on their replication engine, and from my conversations with him, it is basically the same. And then when I like conceptually, and then when I think about the moving parts we have in OpenCFS, it seems pretty much the same there too, which is mostly, we already have the replication stream, and I don't know how exactly how fit for purpose it is right there, but pretty much you're just adding a negotiation thing on the top. It's the two sides talk to each other, they figure out that they do feature negotiation, they do whatever else, but they actually say, okay, well, I've got this thing, where are you up to? I'm up to here, could you replay me everything between 27 and 38? Go.
Yeah, I think the difficult part there is, well, not difficult, but effectively, unlike normal asynchronous replication, the remote side needs to know the transaction group numbers of the things it's receiving. So with normal replication, you don't care. You have the snapshots as the kind of arbiter there. But if you're doing real time, the destination needs to know which transactions it has received to be able to say, I need everything since this transaction group. And the source can easily do that without necessarily needing a snapshot. It's basically the same thing as a bookmark. But unlike current replication, the destination would need to keep track of what transactions it has seen and know which ones it hasn't seen yet.
Yeah, I figure if you wanted doing it pool wide, because we sort of take the easy option, if we did it as a pool wide kind of thing, then you could probably grow the replication stream a little bit to, or the negotiation to basically say, like keep the transactions in lockstep. So that would be a little invasive in the code. But like, I imagine some people would be building it that way. But if you wanted to keep it data set level, which would mean wanting to have your receiver is also be able to have like active data sets, then I guess you need to maintain a like a mapping or a notion of like, this is my peer, and these are the TXG ranges in between, or this is how, I'm not sure exactly. But like I say, I mean, a layer of indirection, every computing solve, but it still seems possible. Like, there are difficulties there, but I mean, it's a fundamentally different kind of system. I wouldn't be trying to remove the existing replication. To me, it'd be
Well, no, I think there's
possibly an add-on, or possibly a different thing.
Well, and to your point there, I think there's an opportunity for a hybrid model where certain parts of it are synchronous. The new things like, the other node needs to know that you're changing this file and don't let somebody read it until you actually have the data. But some of that data transfer maybe still ends up almost asynchronous. And so then you end up with a hybrid model where certain things are synchronous and so other things are more asynchronous, with an f-sync boundary or something in between, to kind of give everybody the right control.
So, Alan,
And
you're bringing up
I was-
right semantics.
sorry, could
I think are actually we're kind of we've blown past them, and like they're not sort of described up here. Is there anything about the right semantics, or say the read from secondary semantics, that you care about, or would you feel comfortable like building this and seeing how it ends up working, and then just saying those are the semantics?
I think some of it is, for example, when we know that a write has happened on the other side, but we don't have the data yet, especially for this hybrid, partly synchronous and partly asynchronous part, we wouldn't want to tell a user who tries to read it that, that file doesn't exist, because we know that that file is being in the process of being created. And maybe we are literally just being like, well, we're just going to pause here and wait for the data to show up and then allow you to open the file and read it, kind of thing. So it's just, that read has really high latency, but does have the right POSIX semantics of somebody called write and it returns success. So when you call open, you won't get end.
we should just recognize that there is a gulf between like real-time primary secondary replication where the secondary is just hot and can be failed over to, but only one peer or one node is expected to be actually making changes, versus an actual like cluster file system, like a multi-master multi-primary kind of model. And we should be clear about what we're targeting. I mean, I know we're just
Yeah, like that's a good point. The difference between
they are
active
quite
passive
different.
and active read versus.
And yeah, and maybe Chris can speak more to this, but I suspect there is probably some amount of demand for just like a more up-to-date replication kind of, or Daniel, I see there maybe has an idea, just would a live but like up to the second kind of live replication be interesting? Because I imagine that that's useful on its own.
That sounds great to me. I think, yeah, I mean, if I could get more real time between, primary, secondary, so twins, basically. So what I'm doing now is I just, whichever one's not read only is the primary. And then I just have two replication jobs constantly pointing at each other. So when the read-only property stops on, goes on one and off on the other, then we just check the written property and replicate the other way. So if I could skip that sort of silliness and just whichever one's primary is streaming to the secondary. That's pretty good. I mean, that's whatever. It's 75% of the way toward what people want from a cluster, I think, in a lot of ways. At least on that level.
Yeah, if I could chime in real
I think
quick.
we
There's two use cases. Again, the DR scenario, where a lot of folks want that. That's great. A kind of an up-to-date real-time DR is fantastic. But then there's also the branch office scenario we see a lot, which is I have folks in Los Angeles, I have folks in Texas, and then the data center somewhere in between. And I'd like all of the three sites to be active in the sense of they're each serving reads and writes and all that good stuff.
Right, and that's approximately 5,000 times more difficult, right?
It absolutely is.
Yeah.
So that's what the very next ask will be.
Mm-hmm.
But that's
So I
architectural
think we
question, the opposite of the other. Go ahead, Jan.
first part, which is, are we talking about a shared disk or shared nothing architecture? But so far, all the discussion implied it's shared nothing.
Well,
And
shared namespace, I guess, really. But yeah, the
yeah, shared
disks would be
namespace, but
separate
not shared
between
disks.
the nodes. This is not.
So you don't have the disks
Fashionable.
via iSCSI and serve reads from the same disk, right?
Right, yeah. These are completely independent pools that are basically real-time.
And the other is, would it be a synchronous replication, as in don't every async write just happens and every sync write gets delayed until it's acknowledged by all followers?
Well-
Or would this be a continuous asynchronous replication which stays as close to the leader as performance allows?
I'm pretty sure Chris's version is the full synchronous, right?
Correct.
It can be, lots of cluster systems will have like different modes for this. How am I willing to serve stale reads from local, which as a file system, I can't really imagine why I would want that.
Right.
But,
I think like the DRDB people had a version where it's like synchronous, but as soon as it's in RAM on the other node, it's okay. And I think what's the geom the hash?
GM Gate does the same.
Hash
Defaults to what
specifically.
they call memsync.
Yeah. And that's I think generally been found to not ever be what people want, even though they think it's what they want. Because it still has the ability to end up, the data doesn't actually get written to the disk. And so I don't think a lot of those other modes are nearly as interesting as just, properly having the, either you need the full synchronous version like Chris is looking for, or, as close as you can get of kind of a continuous replication rather than an actual cluster is good enough.
Especially for the branch office use case, I can see the continuous replication being quite close to what people want, because they either have too much latency or not enough bandwidth to guarantee that every burst can be synchronously replicated.
Yeah, the problem there is without some synchronousness, you end up with a conflict where the file's been modified on both sides, and then there's no way to
I
solve
would
that.
assume that the followers are read-only while they're following, right?
Well, not in the branch office scenario. No, all three nodes have to be able to, legitimately do things, and all of them are actively changing the file system, so they'll need coordination.
The writes are not proxied through the leader.
Well, one option is the proxy to the leader. Another option is some kind of distributed locking, or, that's kind of to be settled by. They're all of those are hard. So, we kind of will have to see which one it makes the most sense in this context.
There is a this is all there is plenty of literature on this. There is probably a question of whether distributed file systems, how far down that road we actually want to go, and are we better to I don't even know what I'm saying, to provide primitives to some degree. Like maybe we want to make it, Luster is already a distributed file system that can have ZFS under it. Maybe looking at that and having a secondary project that is a lighter version of that, or something different. I don't actually know how it works, so it doesn't matter. That's
So yeah, I think
that's
place
something
is to target a scale of 3 to 5 ZFS nodes, whereas Luster is, racks and racks of machines.
Yeah, but maybe there's there's some common primitives that would be better for ZFS to incorporate for another project hand waving away to build on top of, rather than saying, oh, we're a distributed file system now. I don't know. I haven't thought through that at all. I'm very wary of saying, yes, we're going to do, the full fat, network wide quorum friendly cluster file system, because then we'll just die.
For your grandchildren to enjoy.
I hope.
But, that does raise a question that Rob kind of touched on that maybe goes to Chris of, is this always pool wide, or are we opting certain data sets into the replication and having some stuff that is only local?
Yes. Tough call. I think obviously pool wide is the easy solution. I would probably start there. Sure, some people will ask and say, yeah, but I want a data set that isn't, isn't synchronously being replicated because I want performance locally.
But that's a separate pool. Will go away.
Yeah, that's will go away.
If you
I will. Sorry, I've just interrupted someone.
no, go ahead,
If
Rob.
it's
You're-
pool-wide, you're effectively committing people to having at least 2 pools in their systems if they're booting off CFS.
Well, I doubt that you're going to boot off the distributed system. Hopefully.
Or
You need a boot file system, so if that's
That could
not
be a different
replicated
database
as
pool,
well,
right? I could.
yes, so
But-
everyone needs 2 pools if it's pooled back.
Sure.
But on that point,
Most large scale file servers have a separate boot pool. I would hope.
one would
I
hope
would hope so.
our
Yeah.
constituents understand the database level snapshots that get replicated, such that flipping the model to pool might just be a bit of a challenge. But
I also there are things that even if we didn't do like stepping aside, there are still reasons to have some understanding of pool wide or at least multiple data set replication. We have things that and also communication between peers, because we have things that we store that we can't easily replicate right now. We can't replicate like the block cloning table. We don't replicate the encryption route, which has come up recently on the issue tracker. We don't replicate it, but if we're replicating a single data set that has an encryption route somewhere else, and then you change the key, that doesn't get replicated because it's stored in a different place, and so you can end up with a data set on the remote that you can't unlock because the keys, the rapid keys were changed. And it's a little surprising because you don't quite see it. It's like it's a minor bug, but minor. It's solvable, but our replication is very much currently around the idea there is only a single data set and there's only what's on the source, and we have no way for the two ends to communicate, and we have no way to express really like multiple data sets or dependent objects in another part, like in the MOS or whatever. And so there may be some things that we can build to let us replicate those entities, to let us express those dependencies and those sort of things that are also first steps that we will need anyway for a much more comprehensive sort of live two-way replication. Not words. We need a word for this.
While we're thinking of words, I'm trying to imagine what building a data center on this would look like. And I'm wondering what you imagine happens when I unplug the rack that the primary's on. What do I do next?
In a cluster, there maybe isn't the concept of a primary. They're all just peers. And so, I'm sorry.
if you're talking file system versus cluster of servers, for this presenting, that's part of the language is figuring that out.
Okay. So basically, if every node in this cluster has a full copy of the file system, then it, even if you're down to just one machine, it can continue to operate. Although maybe it doesn't acknowledge, it can't fsync any write until it can get some other node to acknowledge, so that you don't end up with split brain. But
Unless
there are
we
different use
select
cases.
some
But
kind of
if this is backing a hypervisor and different VMs are, kind of using different nodes as their primary, they can work without having to spend a lot of time communicating with each other, so that the data is replicated to, your 3 different racks. But you have some kind of idea of data locality where, you're still going to be able to very quickly read all the data, because most of the data you read is going to be data you wrote to this node, and you don't have to wait for the replication as much. But I would say in that case, if you unplug one of the nodes, then everything should still be fine as long as you have quorum. But we also have to decide what quorum means. And if it is only a 2-machine cluster, how much do we allow a node to continue and then, catch the other node up when it comes back, versus how do we sure that the other node is actually dead and not just network partitioned, and we create terrible split brain that will be hard to recover from. I mean, those are not.
So I think this is also, as we sort of touched on this same question yesterday, of like, how much does it make sense for ZFS to do? So this may be a thing where ZFS can provide an underlying replication mechanism, but if you want to have a quorum system, or if you want to have, automatic, leader follower failover, you need to bolt on some extra mechanism that knows what you're trying to implement and does that, rather than trying to expect ZFS to do it.
Garrett, that is basically saying that certain kinds of replication are inherently really stupid things to try. Just fine. But like master, let's say you've got a 3-node cluster. You have VMs that you're writing to. I'm not clear how we're talking to it, but let's say that you're running the VMs on the physical machines, because I don't want to add more networks in here. You've got some VMs running on these 3 different machines, each of which has a big Z pool, and they're replicating between. And Alan just described write once, read. No, it was like read.
I was just saying,
You're accepting a write commit to one, accepting async replication to the rest whenever. You're not doing a write block.
well, in general, we were assuming that we would do a write block. It's just that you wouldn't have to wait for that block in order to read back, because you have the acknowledged copy locally. Like basically, one VM is going to be hot on the node it's writing to.
That's a read form of one in normal, like, distributed database stuff. But like, part of the thing about distributed database conversations is all your clients are remote. So this, like, you don't deal with fsync. Nobody needs this many layers of abstraction from normal database clusters, especially since like DynamoDB. So agree, we need just a word for this, but
this is actually a challenge that file systems, like POSIX file systems, are going to have doing this transparently, because if you're doing a fully clustered master thing, you can kind of like, you build your sharding, your load distribution, your routing into the network, so none of the clients ever know. When I worked on IMAP servers, so this was Cyrus IMAP, and this was we always had a single logical server to where a user's mailbox was assigned was 3 separate installations, 3 physically separate machines, one in each rack and another at another data center. And one was designated the primary at any given time, and it's replicating its changes out to the other 2. And then we do a network-based failover where if we lost a machine, if we lost a rack, if we needed to bring it down or whatever, we would basically disconnect everyone, force all the TCP connections closed, just send a reset, move the IP over to the other rack, make a config change on that, on what was the secondary, it becomes the primary. But the thing about IMAP is all the clients will reconnect, and then the first thing they will say is, I'm up to here, I'm up to this modification sequence number. What have you got for me? What's changed since then? And it would go, oh, here are all your new objects. Of course, all those new objects are immutable, because you don't write over an email. Yeah, it actually had a way to the client was an active participant in the replication, is the way of putting it. And we don't have that.
Yep.
Um,
What you're
so we
describing is
can't,
called
and we can't make that
conflict-free
because the client.
data.
Sorry.
What you're describing is called conflict-free replicated data types, CRDTs.
Yes.
And the great thing about IMAP is, if you use Mailder, Bernstein just solved that by making no updates. But we are definitely not imposing CRDTs on customers, which means that that whole class of database clustering is, you don't get the free stuff that it gives you. So we have to figure out which of the triangle we want to fail on. We want to fail on availability. We want to fail on, I can't even remember the names anymore.
Availability,
Cap.
persistence of, cap, consistency, availability, and partitioning.
I mean, and we can kind of redefine them so that we get a little bit more than 2, but
Let's do this 8 anyway. Wants to dig down, but yeah.
So basically, partition resistance is a requirement. Otherwise, the uptime of the cluster is strictly less than the one of a single node.
Consistency, I think, is with the else.
Yeah, consistency, availability, partition tolerance, but
here's an example
you can
of giving up consistency. You've got split brain on your 3-node. You have hypervisors running on each thing. They're replicating, but your one node thinks it's in an island, and it's still writing to itself. But somebody else on your pair is also writing to it because it thinks that it got promoted, and now it owns the write locks or primaries or whatever for that data set or whatever. It thinks it can write. So then what happens when you try and reunite? Well, that's split write.
Right. Well, that's why I would say, you can't write if you can't talk to the majority of the other nodes. And so
fail on majority.
Yeah.
Got it. Fail without majority.
Yeah, because there's no way to solve the split brain, so we need to try very, very hard not to ever get in that situation.
We cannot. I don't think we can ever have a generalized conflict resolution. But rejoining the brains ourselves. So we have to avoid them, which means we have to.
You need a barrier there until the write is acknowledged by all nodes, because otherwise you get into the question of read consistency, which is an interesting one for a local file system like ZFS, because if someone else writes to a file on another node, when does the write, even if it's not f-sync, become visible?
I mean,
right.
Do you support stale reads?
Where basically there might be, even in asynchronous write, there might be a synchronous component of, a write happened at this range of the file, and that gets pushed to the other nodes, even though the data hasn't arrived yet, because it will come asynchronously later. That node now has to block any attempt to read that range. Basically, we have a range lock saying, somebody's writing to this range right now. You can't read it until they're done.
But at that point, wouldn't it be both easier and more performant to funnel all the reads through an elected master, leader, whatever, and tell you this is the consistent data you're reading? You may serve it from a local disk if you have it already.
Well, I don't know
yes, you may be able to configure it that way, and there are clustered databases that have this notion. That is not necessarily reading stale locally is going to perform better. But routing it through the office on the other side of the country is
Yeah, and I think you're
arduous.
doing a thing that my brain really wants to keep doing, which is you're talking about reads like they're not local operations. ZFS doesn't provide a network read interface, right? Like it's not S3. Reads happen at the VFS. So what does it mean reading from another machine as your primary? That like, are we assuming NFS? No. So like, then what do we mean? Like, assuming we integrate S3, then we can have whole network semantics and like define it to operate like Amazon promises it does, or like Minio instant configurations. But ZFS per se, I don't. I keep talking myself in little circles because doing your reads through a primary when the primary is not yourself, that's not a statement that has meaning.
Of course not.
Okay, so
But-
then what do we want to do?
And basically,
We would have to create the equivalent of that kind of meaningless statement by making sure that the writes are synchronous to the degree that you get the equivalent of that. So basically, writes do not need a quorum, but they need a consensus of all still live nodes. Because then you can just read like a normal local file system, and it would be the writes which pay the replication cost.
yeah, I don't think it would work quite like that. Like, again, the idea is that once, as a write happens, whether it's asynchronous or not, the other nodes have to acknowledge that first, and then once that write is there, we just basically, effectively, the writer has a range lock on it on the distant nodes, so that nobody can read that block until that node has the new content, and that releases the lock. And this way, if you attempt to read something after somebody wrote it on the other node, you just end up blocked until that read actually arrives asynchronously or synchronously or whatever to the node. And that way you always get the consistency between all the nodes, right? If somebody wrote and then somebody tried to read, they won't get stale data. They will get the newest version, even if they have to wait for it.
Alan, are you saying that it would be okay for me to have two different nodes with write locks on different regions of the same QCOW2 disk image that I store? Because, I mean, that is
but you wouldn't.
one definition of consistent, but
Yes, whereas you wouldn't run, like, you wouldn't be having the same VM running on two different nodes. You would run into other problems there.
I hear what you're saying, but I have had customers.
Right. I can't solve that one. But this is more that less in like the VM case, but we're looking at Chris's main example is this remote office case, right? Where there's a video editing shop and they've got editors looking at it from both sides. When an editor in Los Angeles saves changes and then the producer in New York wants to view it, they need to see the edited version, not some mishmash of the local cache that is out of date and what the editor just saved.
Alan, we've talked a little bit about doing stuff with the intent log. So like
Yes, this is my idea of streaming the intent log and adding some new records like, hey, I started writing to this file. You would stream that to the other node, it would see that, and then wait.
Yeah.
Eventually,
and so
somehow the async writes would arrive, and then
so on
reading the file, we don't have to do anything extra. But if someone tries to read the file, we have to tell them, hey, wait until we actually have the bytes.
But then and that it seems like then the receiver for that is the thing that ingests that stream is really kind of like it's a bit like the replay, but it's really like conceptually a kind of another source of syscalls kind of thing. It's like Yeah. So
or VFS
then-
operations or whatever it happens to be.
Yeah, that's operations. Yeah.
You would enrich the semantics with the someone else has the latest copy of this message in the intent log. So any read of that range
Yeah.
will then be blocked until the log is released.
But if you go back to the example from New York to LA, is okay, I'm blocking now for an hour and a half, depending on your network speed. Is that something that is acceptable that however they're accessing it, whether it's through Samba or NFS or whatever, that, hey, there's a file here, it's not ready yet. Now that has to
This would be on a lower granularity, so it'd be the record size. So at most it'd be 16 megabytes at a time. You could have locks on a whole bunch of different 16 megabyte chunks, but they would get unlocked
as they progress.
as they approach. Yeah,
But also,
How is
in
that
general,
it's going to buffer really badly in New York.
right?
yeah,
But
It's got- yeah.
but the file system that is sharing that out has to understand that it's a file in progress, not a I'm done file all the way
well,
through.
the file system would just sort of show what it would be the same as it being. It would be the same as two processors on the same machine reading and writing to the same file, and those reads and writes can be very high latency, like maybe seconds or whatever. So it's going to end up being what the application expects. What if you have an application where one is writing to the file, one copy is writing to a file, and one's reading from the same file? How is the reader dealing with seeing either side of the writes? It's just over a much longer period potentially. But that seems like that's entirely an application level thing, because we don't know what you're doing.
I think
That's
that's the
possible
point
work.
that it might be very useful to be able to give feedback to the application that that's why this is happening, or even like possibly
I mean,
some way to return E again or something to tell them like, yeah, this read is not, this is locked. It's going to take a long time before you can have this.
Yeah. I mean, yes, it would be great. I don't know if we have the interface for that.
Yeah, and I don't know that. Yeah, like we there's no POSIX thing to tell the application that, hey, it's gonna be a while.
Yeah, I mean, it's, if somebody's using Avid and they were waiting for a lock to unlock as part of that write, okay, now what happens?
Would readers block future writes for the same range? Let's say I have a file and it gets updated in place by the application, just overwritten the same file range over and over, faster than the replication bandwidth. Will the reader block forever, or will the reader
So the read's gonna be blocked.
block future writers
So-
until it has caught up for that read operation?
Right. So the reader's going to block for a specific transaction group. So once that one replicates, it'll unlock, they'll do it, and then the next transaction group would have it. Because the user needs to get the version that it should have been when they tried to read it.
What happens is
the
the
next version,
is
but
split
what would have
between. What happens if a write gets split across multiple transaction groups? Let's say I do a single write system call with a 10 gig file.
A write doesn't
So-
get split like that, because that
Yep.
that write, like you can write 10 megabytes or 10 gigabytes or whatever in a single call. It will still be split up and stored into multiple chunks. That is not one write as such.
Yeah, like ZFS on Linux has a tunable that controls, like, no matter what size you write, it only comes down to the VFS layer in chunks of a certain size. And I think the default is 1 or 16 megabytes, something like that. But in the end, it would be at worst like the record level in ZFS. And so each record either got written or didn't get written in a transaction group. And so, but it does raise an interesting question of if someone has a read locked when we're streaming the ZIL, how much should we let them block us up if they're, I don't know, holding the lock and being really slow reading it for some reason?
And just throw another bug in it.
because that's what I do. Having a bandwidth limitation on how that sync can happen. I cannot use the entire bandwidth available.
Right. You want to QoS the replication.
Exactly. I'm doing it in rsync now. I need to be able to do that with this logic. So not to lose it, but that is something that would be a requirement for actual production use.
And that's why it's really important to separate the synchronous and asynchronous parts of this so that you can prioritize that, the communication of that lock separately from the streaming of the data that would unlock things.
And by pool or by data set to say, hey, this one's replicated as fast as possible with a 90% priority. Everything else fits in that 10% as it goes through. And yes, I realize it just got really messy really quick.
Yeah, you just want two ponies.
Yep. Two-headed pony.
So I do hate to point this out, but this is both a really hard problem and one that other people have solved, whether in research systems or in actual products. And so again, I want to say, is this a problem that ZFS specifically needs to solve?
Yeah. I was just thinking, I've never run NFS. I don't know enough about it, but so as an example, I was just thinking to what extent is this reinventing NFS? To what extent can we just, or something else, but to what extent can we just provide additional help so we can do replication stuff under the hood, and then we can provide hints, help to the thing that makes it available to clients to understand what's happening. That's a question. I genuinely don't know the answer.
So here's my probably misinformed take. Listening to Alan, it sounds like the semantics need to happen around not file rights, but around
not addresses, but
records.
records. Okay.
Records.
So
Files aren't real.
yeah, right. But not whole records, because it can be regions of files. So
Yeah, but it's always atomic at the record. So
it's always atomic as the record. Okay, that's good to know. So the issue for me is if it's sub file, what's the advantage of this over doing ZFS on top of distributed block storage? So that can be DRBD. There's various options, but
basically the ability to have the same pool imported on 3 nodes instead of only 1. That's effectively what this would be, is the fact that you can read from more than one system. Like you can build ZFS on top of something like S3, and then if it crashes, be able to import the pool on another node and get it back up real quick. But that's not the same as actually being able to actually read from more than one node at a time.
why would having DRBD to 3 nodes and then ZFS reading from those block devices not
Just you
provide
can't write in that way. Like ZFS doesn't allow the same pool to be imported on multiple systems like that.
And so, but user ZFS would.
Well, even kernel ZFS would if you had this ZIL stream.
If you have one that is in write mode and 16 that are in read mode, you can't do that right to the same storage.
Right, you can't even have a second ZFS in read mode because it would need to know every time something changed that it needs to invalidate its CAC.
No, but exactly, and that's where that capability is in user land, which I think
This is not specific to user land. It just might be a bit easier to do in user land, but none of this is dependent on user land.
but being able to say, hey, keep it really simple. I've got two hosts. One is read-write task to my JBots. The other one has the exact same visibility JBot. Everything naps the same, physically match. I could mount that other one read-only and have no cache until I get read requests. Does that solve the problem?
Not the multi-office problem.
Right.
It solves some problems, and like we were looking at something like that, a lighter version where it was just I'm about to do a controlled failover. So can I get the pool imported read-only on this other node and get a lot of the slow parts of an import done, and then coordinate just flipping over the right bit, and then this node's going away? But if you import a pool read-only, it doesn't start a bunch of threads, and there's no stuff you have to do. And there's a lot of assumptions that, like, even without the cache, just you have to actually reread what happened on the disk because things about the pool could have changed. Or even like what transaction group number you're at. You don't know how frequently the other node is changing the most recent transaction, and so you never know what transaction you're at.
Well, and the use case from that is a CDN. I've got a CDN that's getting content in, and I've got multiple nodes sitting everywhere around the world talking to it to be read.
But do you need it to be that synchronous versus just using replication?
See, again, just maybe.
Possibly, yeah.
Yeah.
Having operated a CDN and tried to use ZFS to replicate TrueNets for their downloads, I know the complexity of balance. But yeah, what you're talking about of basically being able to have a read-only import of the pool on the second node, especially if they're maybe SAS multipath to like the same physical disks, has a whole set of advantages and a lot less of the complexity. It's just how much ZFS has to keep invalidating its in-memory representation of what the pool is because things keep changing on disk without it ever knowing about it.
Right. Because I mean, what
So
what
for
we're
that,
doing right
the
what we're
content
doing
log
right
will
now.
have to change to log which ranges on the disk have changed so that the followers could invalidate or update their cache of that region.
In this case, it's not so much about the data. It's literally like the structs in memory in the kernel of like, what transaction group number are we at? If somebody creates a data set and we've imported the pool, we don't know that that data set's there. Whereas if you were on, when you're on the main one, you happen to have seen the actor that created that data set. But if you're importing that same pool read-only on a node, you don't know that somebody went and created a data set behind your back. And you can't just like throw away and re-import the pool every transaction group to hope to notice those because that's a lot of overhead in it. Right. What do you have to do in the middle to get there?
So back to the earlier conversation that apparently this morning was cluster day because there are at least 3 different conversations going on about it. But real poor man's clustering is those 2 nodes talking the same set of JBods, boot up, one imports the pool or pools, runs application, everything's fat, dumb, and happy. The other system is up running, it sees the drives, it doesn't do anything to them. You down it, you bring up, you do the import, you start the application. That is acceptable for 99.9% of the customers out there. If we can help orchestrate that versus having to cluster anything, okay, now it's a minute outage. If we can get that to a 20-second outage.
We've deployed that concept hundreds of times.
Right. But that's the thing that we can, as a group, say, hey, this is the right way to do it. And as part of our documentation or whatever, here's a sample architecture to do it the right way.
Yeah, you
really don't need 2-second outages.
Right. And we've been looking at adding things like, I forget what we called it, but a zpool command that would do some of the stuff that happens during export early, like condense the space maps, finish reading all the dedupe logs and writing those out, and all the stuff so that, especially in the controlled failover rather than the unexpected failover, that we can get the amount of time it takes to export on the old node and import on the new node down to the minimum by having processed all the space map logs and all the dedupe logs and basically make everything as fast as possible. And then the thing we were just talking about of, can we kind of get a pre-import going on the other node so that we know where all the disks are. We've figured out a lot of the stuff that isn't going to have changed during the couple of minutes between when we're starting a failover and when it's finalized. Like pool config stuff, but we can't make any assumptions about the dataset.
Does that make sense doing on a routine basis anyway? I mean, how heavy of a footprint is that to just do that?
The zpool condense command? I mean, like in general, most of the tasks are kind of doing that as the pool's idle and keeping it short. It's mostly kicking that off, just like in some of our customers' use cases, like, all right, if we're going to fail over, we're now saying, let's drain the load off of this node. And so during that time when they can't turn it on yet, but it's under less load, we can get as much prep work as possible done so that the failover can be as quick as possible to get that window from 60 seconds to 30 seconds or something. But yeah, the goal is 30 seconds is too hard. Yeah, staged export. Yeah, and kind of pre-staged import.
Over a SaaS fabric or a network fabric? Because
SaaS.
and 99.9% of users don't have SaaS, do they? So I think we're talking about a few different things here. And
Those JBots? I mean, yeah, he's got hundreds of.
oh, he does. I don't doubt that.
I've got thousands of them. So I mean, it's.
So we're at the hour mark, and we might want to break, having just had lunch, such that I'm hearing us go from real-time continuous replication of data sets and snapshots as we know them up to the ultimate clustering file system on planet Earth that might take some time to get here. And then the HA with JBods and how we can simply make that better for our users, as we kind of continuously do already in various ways. But in the context of strictly user space OpenZFS and a 3.0 release, do we have like one concrete tangible goal we can just slam on there?
Well,
A remote question, perhaps?
we do have a couple.
Okay, bring it on.
On the Slack, Alex Pinchuk wanted to point out there is a probably pretty divergent now user space OpenZFS fork at GitHub Mayadata-IO C store, and that they do have a synchronous replication library, which is libc store. So that is in there. And on Zoom, Admin White was pointing out that dual head node share JBOD works for most cases, providing a good reference architecture that can go a long way. How much time can be saved by draining a node like this?
So a lot of the time in an export in the past was freeing the memory, and we made that be able to be done asynchronously after the export. Especially, in the case where you're taking the node down to upgrade the operating system, spending a bunch of time waiting for it to free the memory when you're about to reboot is kind of a waste of time. But so that's the asynchronous freeing of the memory in the background is in 2.4. Maybe 2.3. I don't remember how long ago it was, but it's in new releases. And then, with the zpool condense thing, you can get the space map logs and the dedupe logs and so on out of the way to make the next import that much faster. But most of the time it's going to be relatively short. One of the other things from my talk tomorrow of using the new larger label to have the complete pool config on every disk's label could mean that reassembling the pool during import can be faster as well, instead of having to search every disk and figure out, hey, we know there are 8 VDEVs, and this disk tells me about that VDEV, and keep looking until you find 8 VDEVs that all happen to have the same pool grid. Instead being like, hey, I found a disk that's part of this pool, and I know that every disk now can at least help us more quickly put them all together and have hints about where the disks are. Even if we have to fall back to searching when things aren't where we expect them to be because JBods and so on. It could, again, every little bit that helps to get that amount of time down so that, your SaaS, dual-headed SaaS system is a fast enough failover that you can convince people they don't need a cluster. Which, like, when you're doing the satellite office thing, like Chris is talking about, it's not good.
Either application versus failover replication.
Very different things.
Have we invented the TrueNAS hardware of a non-transparent bus and the synchronized slog and all those things that allowed you to have 2 controller nodes and 1 JBOD, and we're just trying to do that?
The non-transparent bridge for the slog is extra goody for that kind of system, for sure.
Okay. So let's do just some takeaways and take a break. Someone somewhere make a list of how we can further speed up the import of the pre-import of 2 of a pool that will be in perhaps other, 2 nodes. I'm no longer hearing anything about continuous replication where, okay, how do we just set it and forget it? And we know these two systems stay in touch with maybe a higher level notion of reversing that process.
Continuous replication seems interesting at first, but then it's not that much better than the regular asynchronous replication, and it's not good enough for the use case where you actually need the full synchronous, like, this write. Don't tell the application this write is done until it's on both nodes. And so it's this weird middle ground that maybe is not better enough and not good enough at the same time.
Fair enough.
And it can still be interesting, and it's a more reachable banana. So
Well, and you also have that a lot of the applications now do it themselves.
yeah,
And Postgres is a hell of a lot more efficient than it was 5 years ago in doing its own cluster replication. I mean, that just works.
if it's a database, you want the database doing the replication on 3 independent Z pools, not trying to have all of that happen behind those under these are bash.
Right.
So in the context of OpenZFS release 3.0, beyond the user space, possible component, is there anything that really ties in there? And we have a remote question?
Well, this isn't a remote question. It's just, I keep saying this, the application always knows better about how to deal with its replication than the file system ever will. And there's nothing we can do to change that.
The way I've looked at it is you need to have smart writers so if you have CRDTs, what happens when you get a write conflict is it hands it back to the writer, and it's the writer's job to resolve the conflict. So you've got that in all sorts of different distributed databases. That's what you need. You can't do that with a POSIX file interface. So to support POSIX file interface, we cannot give the level of consistency that people expect from clusters.
And so you get to buggers.
Which is not POSIX. Right. Exactly. Yeah. We do buckets. We can do that. Like there's lots of subsets. Write only. We can do that. But you want to be able to do arbitrary reads and writes from addresses within a file. You want to mmap against something? Good luck.
And that's a whole day.
Okay, so that is indeed the perfect segue to a discussion of object storage. So let's take a break. See you in a few. Thank you so much.